let's, for like close to 30 minutes, we'll talk about this problem statement of Hugging Face, and then let's see how this. Okay. Um, okay, let's start off. Here, if you go into Hugging Face and if you go into models, you'll have multi-model computer vision, NLP, and all of that. So this is all part of AI. This is a Git repository. If someone has not attended a discussion last time that we did, so this is a repository like GitHub or Git for AI related documentation. So here we are going to do visual Q&A, visual question and answering. And for folks, uh, I had sent this out. Um, I had given a very introduction of what visual language, such as let's say charts and so on and so forth, how can we understand and take questions out of each one. So here we are going to do one such activity. Here we are going to do visual Q&A. We are going to do dplot. So imagine if you have a chart, what are the textual information that you can take out of it? If there is a histogram, and there are multiple questions that are asked, which is the highest, which is the lowest, and all of that, you'll be able to understand such ones. So that is visual Q&A. So you have many such images that are given to you, which has numbers and where you can derive a story out of it. Greatest examples being use of such charts and such numbers in any sort of sporting activity, like cricket, for example, or any sort of Olympic sport, let's say javelin or shot put or soccer, football, where all these numbers are coming up on the screen. And with your AI algorithm, you are able to depict certain key points. Hey, so and so, this is the highest, this is the lowest. If you are given a data set, you can tell that, okay, you can pick out a data point in the last 30 matches that India has played. It has won gold in all the matches. It has won silver in all the matches. The data might not make any actual sense, but you can give it out to the storyteller who is the commentator. So sort of. So that's the application of this, where you are plotting. So what you're doing is, first, I'll just not go through the code. I'll just talk about the story and I'll talk about the problem statement and the application, and then say how how this entire algorithm works, and then we'll go into the Python implementation of this, right? So simple. Again, I'll repeat the problem statement, which is that we are creating a question and answer story or a data point from visual images. These might be charts, these might be plots, these might be any sort of quantitative data in a pictorial view. So here, first, what happens if you take a look at this image? You have let's say a chart, a histogramic chart, where you are going to deplot it, and a question is asked to the LLM. Right now, with the existing LLMs that we have in the market today, right? So we have, let's say, we have Chat GPT, we have Bing, and all of that. If I give an image of this one, it won't be able to help me understand this. So if that is the case, let me take out an image. Let me. I'll show you. Let me take out a metric. Let's say this is the image. Okay. I will save this image, right? And I'll try to give it in to this. and it won't be able to give out a really good answer to me on this front. So there are other LLMs as well. So as AI engineers, what we'll be going in is doing such problems and making the LLM far better. That is, so if I'm just seriously defining the problem statement, key, what is the LLM not able to do? If LLM is not able to do, or large language model as we call this today, is not able to do this. I do not have ChatGPT 4. We have moved ChatGPT 4 into Bing Chat. So when you take a look at this is giving me an answer, which is y-axis divided into two increments, so and so frequencies give me more insights. If I ask, okay, give me more insights. So this is ChatGPT 4, GPT-4, and it has to give me such data points out of a particular chart. And how is it going to do this? Unfortunately, if you take a look at two LLMs, this is another LLM which is and I ask, give me the right data points. It won't be able to accurately give me. And folks today are working on this particular problem statement throughout the world, right? So you clearly see a difference between what this particular company, whose LLM that we just used, is not able to give me any sort of numbers, right? And I did ask, hey, give me the right data points out of this chart. No, it couldn't. Or is it failing at convolutional neural network, which is a question within a question, like how we do a question answer session. I ask you a question, you answer, and then I ask you a question again, and you take in the previous question as my context and you answer. That is one great ability of an LLM that it is not able to do. Maybe that might be the problem. So you would have to go through and check, right? So this is the output of this. When you take a look at this is the output. I'm getting numbers through which, if I am a commentator, if I am a broadcaster, or if I am a political analyst, I can create a story out of these numbers by looking at, hey, the highest in so and so graph, any sort of data, or even if at a business context in an enterprise, someone is viewing this chart, and if given out, let's say you've plotted this chart on a Excel pivot table, so you put it in an LLM, let's say Bing Chat Enterprise, you are going to get data points and you can create a story in your 30-minute meeting. So that is the aim of this, and we have to make this sort of response from the chart better. How are we going to do this? Is through this. How is it working? Is first it's going to deplot. So we will write a couple of lines of code in deplotting the chart into this, and then an LLM question, large language model question, is asked, which let's say it's going to go through every single piece. Let's say it's going to find the average of the deplot across two sets if there are multiple tables and all of that, and then it's going to give you this. If you take a look at one more platform called as Cdac, so it was part of GPT-3. It's not part of GPT-4. So it is going to define. So what Codex used to do here is that it is going to define your entire table, which is from a plot. It is deplotted and it is put it into a table format, rows and columns format, and then Codex would help you go through the normal questions. What's the average of the numbers here? What is the greatest, what is the smallest, and all of that. So here we want to make this entire storyline better. So we'll go into the solution part now. Solution part being, this is the simplest. Okay, I don't have VS Code installed on this machine. So okay, we'll try we'll try going through the code here. Here we are looking at writing transformers. We use a particular library. So whenever any sort of library that is used, we are also doing such libraries in our assignments and in our Python class. But whenever such libraries are used, try to go through what that library actually talks about, right? What is this library? What does this library actually do? So this is the library construct pix2strut processor, which wraps bird tokenizer into pix2 struct image processor into a single processor. So this is a library that's written in Python. And what does this library actually do? Right? That is what is needed. And what is the syntax of this library? And how does it actually work? They've given you a image of that. So whenever you're writing any sort of AI algorithm, we are going to use libraries which are different from the normal libraries that we are doing in classroom right now with Python. So what are these libraries is something that we should always understand. And what does this library do? What is the syntax of this library? What's the structure of the entire code? And what are the parameters that this library contain, right? So this library is essentially working on a bird tokenizer. What is a bird tokenizer? This is a research paper written by Google, which is, it's a language model. Yesterday, I think we were doing this, which is pre-training of bidirectional transformers for language understanding. So this is the transformer on understanding a particular language, and a token gets generated. Now this particular library acts as a API module which generates a token. So every time you use this library in your Python algorithm, it creates a token and executes the subsequent lines. So this is what, and what are the parameters that is there. So this library is specifically used while doing dplot, which is that you are trying to weave a story or data point out of a chart and take out multiple data points and then weave a story out of it. So what are the data points that it is looking at? So, or what are the parameters that it is looking at? It is looking at the text within the image. It's looking at the vision config, right? And the text config and the vision config and all of that, this is there. So when you go ahead and when you work with different libraries in Python for specifically machine learning and AI, machine learning is different. So you're going to talk about NumPy, pandas, and all of that. These are the libraries that you're going to work with. You want to understand, and the questions that will be asked, or the understanding that you need to have as AI engineers, is what are each libraries used for, right? It's a good habit to even kind of like mug up all the libraries on what function that they do and what is the syntax that each library has. But if you work with such libraries every day, you will be able to do it. And while writing algorithms as well, while writing AI algorithms as well, writing the libraries is very important. And if it comes naturally, it will be of great use. So pix2struct, structuring the pix2strut text config, this is the one. And then vision config, so and so, is the one. And then, so this is the example of such. The parameters here is what is the vocabulary size, what is the hidden size, what is DKV, what is DD, DFF, what are the number layers, what are the number heads, and all of that. And token ID is how many times are you going to use that particular library in running in a module. So every token is, hey, I've asked a question, on top of this one token gets generated and it is giving me answers. I ask the same, another question on the same chart, it is generating another token and it is giving me. So it is at a great point on the commercialization bit as well. The number of questions you ask, we can build them in the same way. Or it is also for us as a recording, that all the questions that are asked is stored under that particular token. So tokenization is used for that, right? So it can have two uses. One is that you use tokens to bill that, hey, we gave Bing Chat or we gave this sort of an LLM to you, and from X first day of the month to the last day of the month, or the last day of the 3 months, a quarter, we you guys generated some, let's say 10,000 tokens, and for each token so and so is the bill, and you have to pay so and so, right? That is one way of using tokens. Second way of using the use of tokens is, what questions did we actually ask to that particular plot image will be stored under that particular token. Now, how are we going to use this is that, okay, what are the probable questions that one can ask? If you take a look at this particular LLM, it is not giving me an output of, hey, what are the probable questions after this that other people have asked, right? Or in general humans ask, is something that this LLM is able to give me. Hey, what is the difference between histogram and a frequency polygon? How do I interpret histogram chat? Let's write a story together about this. And it is giving me a suggestion of other images as well after giving me an output. So that is how your tokenization can be of help. So if I click on this, let's write a story together. I'm wanting to see how good a story that this is connected to. No, it's not. I would say connect the story to above plot. So it is able to create a story. So that is how your entire tokenization works. What is a pat token ID for every question, and what is the sequence token ID? Now, sequence token ID is convolutional neural network, that it is the first token that is generated on a particular image. Let's say first token that is generated on this image, the first token will be this is 1. The next question that is asked, this will be 1.1, next will be 1.2, next will be 1.3, 1.4, 1.5. So multiple conversations are developed on the first piece, and then the cycle cuts, let's say at 1.5, and then a new image is inserted, and then it starts with 2. I hope that you understood about convolutional neural networks. A question inside a question, so that the previous question is taken in as a context. So that is the use of this tokenization or this particular model. So here are 2 points to keep in mind on which library, and second, tokenization and different parameters. So when you take a look at these libraries, right? So on the back end of such an LLM, with using Python language, many Python libraries are created across text generation, across visual question and answering, across all these problems that are there. If I have to use, okay, across, let's say, across all these problems of multimodal, every particular part of this model will have a library or multiple libraries that are written in feature extraction, in visual question and answering, document question and answering, graph machine learning, and all of that. So there are so many libraries that be used behind this LLM, and those libraries, each of those libraries will have parameters. Now, what are parameters is, what is a vocab size? What's the hidden size of the plot image that is there? What are the number of layers? So these parameters if you take a look at this, right, what is the initialization factor? It is given. What does it mean? What is the sequential rendering? If I say, what is the relative attention of to number of buckets? So these are parameters. When you take a look at all such Python libraries, or like libraries that are written behind an LLM, the efficiency of an LLM is that it can, the higher the number of parameters, the better the LLM is, right? Right, a particular library might have, let's say, this might have 15 parameters. Another library might have 20 parameters that library is able to capture in a particular image. So if more the number of parameters, the better the library is, the better the algorithm, large language model is. So on that front, Bing, or let's say GPT-4 has 75 billion parameters. It might be across different libraries, but it has such 75 billion parameters that it is able to detect in a text, in an image, and all of that. So whatever, if GPT-5 comes up or if GPT-6 comes up, they are mainly working on increasing the parameters. That means they are working on different library sets. So when you say a human brain works on multiple thoughts, in a day we get around 65,000 thoughts is what the entire research is today to understand the universe. So what are the difference in a segmentation of those thoughts? That is what this particular company is wanting to research today, is that a human brain gets 65,000 thoughts in a day, out of which 95,000 thoughts are just repetition of yesterday's thoughts. So how can you segment that? How much of these 65,000 thoughts are images? How much are text? How much are short, like PowerPoint slides and videos? How can we segment that? And then how can we write libraries which will be able to capture that input? And what are the parameters within it? So if we go on increasing the parameters, it might go above 75 billion parameters and with more number of libraries. So as AI engineers in implementation of AI, you'll be tasked to use these existing libraries, or if you're doing AI research, you will be asked to, given a scenario, can you write down the parameters and write the syntax for it and do a couple of such execution setup, execution of that problem, like let's say visual QnA. It can be, let's say, a pie chart here, or a bar chart here, or a histogram, and all of that. So here we'll again now go back to our problem here. So from transformers, this is the library that we are going ahead, and this is conditional generation. That is what, and we import a request from this image. So we run this particular library, which is acting as a processor, and we are going to use a particular pre-trained model, right? The model is so and so. So the main factor being this library, which is here we are using the same one, right? Pix2 strut processor. What does this library do is something that we talked about here. Then we give the URL of the image. It's a PNG file, whatever the image is. It can be from your local machine or a web URL. And then we open the image, we do a request, and say that this is true. And what are the inputs? So it is just a 8 to 10 line sort of an algorithm, but the complexity that is there within this library is what we spoke about in this entire setup, right? So we'll go to the last 3 lines of the solution, which is inputs. It processes the image and generate underlying data table of the figure below and return tensors as PT. And prediction model generate and the maximum token is 512, and then you print the process. So Google has done another amazing bit on this called as TensorFlow, where such conversation inside a conversation can be done, which is that here um, generate underlying data of the figure table. The maximum token that can be generated is 512. So on the back end of TensorFlow, a lot of GPUs are connected, graphical processing units are connected, and it is able to process your question within a question and it can respond back. CPUs don't have that power. Unfortunately, Google doesn't have a node in India. It has only one node in Asia, which is in Singapore. Um, at the moment, as I'm speaking, I don't know if they plan to come in, but because of the node presence in a faraway location, the response and the yeah, usually the response time, the latency of the response from a GPU is very low. So, so that is the entire solution to this. So if you can read more about the work that this person has done, Fang Yu Liu, on this particular problem statement. Right? I hope this is useful. I'll stop it here. Happy to take any questions or to understand the problem statement even more.
भाई ये जो इमेजेस का जो है, मेरा आवाज आ रहा है क्या?
हाँ हाँ बोल.
ये जो इमेजेस का तुमने चार्ट का जो बताया, ये अभी कौन कहाँ पे यूज करता होगा, क्या लगता है तुम्हें एग्जैक्ट करंट सिनेरियो में?
करंट सिनेरियो में अगर तुम एप्लीकेशन की बात कर रहे हो, तो वी आर राइट नाउ आई एम सिटिंग इन अ कॉन्फ्रेंस रूम, राइट, एंड समवन इज प्रेजेंटिंग अ स्टोरी हियर and he wants to prepare for this meeting or the storytelling activity, and वो उसके पास बहुत सारे charts है. What are the sales that have happened from, let's say, from the last 3 years? He has all the charts, he has all the data in Excels and all of that. Now if he feeds those output charts in a pivot table into the LLM, it is going to give out a point. The highest, this is the highest amount of sales of Asian paints is in this particular village in India, in this particular village across Madhya Pradesh, right? The highest usage of nodes, GPU setup is coming from this part of Asia. Let's say it is coming from Israel of Asia. So with that, he's about to tell a story and he's about to give a direction to the team कि किस तरफ जाना है. So all of that, this visual QnA can be used. This is one place. The other examples that I spoke to you about was, let's say, sports commentary, any sort of sport. So hockey, swimming, football, cricket, there are a lot of data that are coming in, but if a human eye looks at it, it cannot immediately take out, if it's not a trained eye, it can't immediately take out the highest, the lowest, the average, across these 10 matches, how much did Shubman Gill score and all of that. So this visual QnA AI algorithm will be able to give you that. The other example might be in a political analysis of data, all of that. So it is about data insights through this particular problem of visual question and answering. Within that, there might be many libraries, and we just spoke about one library.
और ये जो टोकनाइजेशन है, वो
टोकनाइजेशन हर के लिए कॉमन है. बर्ड टोकनाइजेशन का फॉर्मेट कुछ अलग हो सकता है. इट कैन बी 15 digit tokenization or a alphanumeric tokenization of 10 digits, 10 characters and all of that. Tokenization ka, which is, I did explain, I'm just repeating it, which is the use of that tokenization is for billing, or how many questions were asked within each one. Second is to understand how many questions were asked on the same topic. Like is token 1, 1.1, 1.2, 1.3, 1.4, and then second image is put in, so 2, 2.1, 2.3, 2.4. Or within that, it can go even deeper, which is 2, 1.2.11, 2.12, 2.13. So we can increase the complexity of tokenization.
Okay.
Any other questions? We'll give it one more minute and we'll close it at 9:50.